Welcome to solverfy.
In this problem, we are given the wave function for the hydrogen atom when it is in the state of 200. This is the principal quantum number n, this is the angular quantum number, and this is the azimuthal quantum number. So n, l, and m. We are given that this is equal to 1/4√2 pi e power minus r over 2a into a power minus 3 over 2 minus 3 over 2 and 2 minus r over a. So our first problem is to show that the chi-square that we get is consistent with the plot that we have already observed in the text. So we need to make sure that this is similar to the figure 39.21. So let's plot this function. So we'll first try to plot the chi-square function. When we plot the chi-square function, we get a curve like this. Now, if you look at the 39.21, we have in the center, then we have a cloud around it of dots. We have a gap, and then we again have a cloud around with dots. Maybe this one is a bit more. So as you can see, this is similar to this region. So as you go away from the center, the dots keep reducing. Then there is a complete dip, which is this region where there's no probability of finding the electron. And soon after the dip, the probability again rises, but it's quite low compared to the initial. So this is that region which is a bit flat, so it spreads out. However, the probability of finding is very small, so the dots are very loosely spaced, and then it reduces. Beyond this, it is completely zero. So this plot that we generated is consistent with what we saw in figure 39.21. This solves part A. Now for part B, we need to show analytically that the chi-square function has a maximum at r is equal to 4a. So we need to show that this value is r is equal to 4a. So let's do that. So for doing this, we will notice the fact that when we square this function, we get that the chi-square is directly proportional to e power minus r over a and a minus 3, which is not important, and of course r minus 2 over a whole square. In order to find out the maxima, we need to differentiate this function. So we differentiate this with respect to r, and then we try to find out. So and we should equate this to 0. So when we differentiate and equate to 0, we get an equation like minus 1 over 32 this is the equation that we get. So as you can see, this equation is equal to 0. It has two roots. The two roots are r equal to 2a, which is when this part goes to 0, this term, and then there is another one which is r equal to 4a. So we were right that we have a maxima at r is equal to 4a. Now what we need to now search is, since d square xi over dr is equal to 0, this only shows that there are 2 points at which the slope is equal to 0. So one is this point which is r is equal to 2a, so I'll write this as 2a, and then we have another point which is that r is equal to 4a. As you can see, 2a corresponds to the minima, so this is the point of minima and this is a point of maxima. For our next problem, we need to find the radial probability density at this point r is equal to 4a. So we need to find the probability at the point 4a exactly. So we do that by taking the volumetric part, 4 pi r square into psi square function at the point 4a. The answer to this can be easily obtained. We square all the function and then we square this function completely, and then we multiply with 4 pi r square. So the value that we obtained is r square over 8a cube. So p at 4a is equal to r square over 8a cube into 2 minus r over a whole square, and that comes from the other term, e minus r over a. Sorry, this was at some variable r, not at 4a. So we will change that. In the next part, we need to show that the net probability density is equal to 1. If that is so, then we say that the wave function is completely normalized. So we need to prove this relation. So we begin by taking this value, which is, once again, this is not at 4a, this is a general value of a, and we need to integrate this function. So we take 0 to infinity r square over 8a cube into 2 minus r over a whole square e minus r over a dr. Now that's equal to 1 over 8. We'll make a substitution, and the substitution is r over a can be taken as x. So we make a substitution of x is equal to r over a. So in that case, this becomes equal to x square into 2 minus x whole square and e minus x dx. The solution of this is a bit cumbersome, but then the value that we get is 1 over 8 4 factorial minus 4 into 3 factorial plus 4 into 2 factorial. And as you can see, that's exactly equal to 1. So we have proved that the entire probability square integrated is exactly equal to 1. So this wave function is normalized.